Skyscrapers define our city skylines, but inside, they face a major challenge: heat. Imagine a glass tower baking in the sun all day. Solar energy pours through the windows, turning the building into a giant greenhouse. This solar gain quickly raises the temperature inside, even on cooler days. The beautiful glass that gives us stunning views also lets in a lot of heat. Engineers must calculate this solar gain to design cooling systems that can keep up. But the sun isn't the only heat source. Every person inside acts like a tiny radiator, and in a packed office, that adds up fast. Computers, lights, and other equipment generate even more heat, creating a constant internal load. All this heat means skyscrapers need powerful cooling systems just to stay comfortable. There's also the stack effect. Warm air rises, creating a chimney-like flow up elevator shafts and stairwells. This can make upper floors even hotter and complicates cooling. Engineers have to design systems that counteract this effect and keep temperatures even from top to bottom. The challenge is unique to tall buildings, managing heat from the sun, people, and equipment, all while fighting the natural movement of air. That's why skyscraper cooling is such a fascinating engineering puzzle. The taller the building, the bigger the challenge. It's not just about comfort, it's about making these vertical cities livable. Keeping it cool is a feat of science and design. They're complex environments battling the sun and the laws of physics. And it all starts with understanding why they get so hot in the first place. The answer lies in the building's lungs, the HVAC system. So, how do skyscrapers stay cool? The answer: HVAC heating, ventilation, and air conditioning. HVAC is the building's lungs, constantly circulating and conditioning the air. In sealed skyscrapers, you can't just open a window for fresh air. HVAC is the only way to keep things comfortable. These systems do more than cool. They control humidity and filter out dust and pollutants. With thousands of people inside, the demand for fresh, cool air is immense. HVAC systems must be powerful and reliable, working around the clock. Ventilation is key. Fresh outdoor air is drawn in, filtered, cooled, and distributed throughout the building. Stale air is exhausted out, preventing the buildup of carbon dioxide and indoor pollutants. This constant exchange keeps the environment healthy and pleasant. Engineers design these systems to balance temperature, humidity, and air quality. In skyscrapers, every breath of cool air is the result of careful planning and powerful technology. The HVAC system is truly the unsung hero of high-rise living. Without it, skyscrapers would be stifling and uninhabitable. The next time you feel a cool breeze in a tall building, remember the complex system making it possible? It's not just about comfort, it's about survival in the vertical city. Let's look at how water and air move through these giants to keep them cool. The journey starts deep in the building's core. Welcome to the world of chillers and air handlers. Cooling in a skyscraper begins in a central plant, often hidden in the basement or a mechanical floor. Here, massive chillers cool water to just above freezing. Powerful pumps send this chilled water through a network of pipes to every floor. On each floor, air handling units use the chilled water to cool the air. Warm air from rooms passes over cold coils, transferring its heat to the water. The now cool air is blown back into offices, while the warmed water returns to the chillers. Ductwork distributes the cool air throughout the building, while return ducts bring warm air back for recooling. This creates a continuous, efficient cycle of cooling and air movement. Engineers carefully design pipes and ducts to ensure every area gets enough cool air. The system is precisely controlled to maintain comfort and save energy. It's a silent, orchestrated dance of water and air, happening above ceilings and below floors. Without this system, skyscrapers would quickly become ovens. The movement of water and air is the lifeblood of skyscraper cooling. It's all about delivering comfort to every corner, no matter how high. Next, let's see where all this powerful machinery is hidden. From basements to rooftops, the real action is behind the scenes. The heavy machinery powering skyscraper cooling is hidden in basements, rooftops, and special mechanical floors. In the basement, you'll find chillers and pumps, the heart of the cooling system. These machines generate and circulate chilled water throughout the building. Basements are chosen for their structural support and to isolate noise and vibration. But cooling isn't just about making cold, it's also about getting rid of heat. That's where rooftop cooling towers come in. Warm water from the building is pumped up to the roof, where it's cooled by evaporation and fans. The cooled water returns to the chillers, ready to absorb more heat. In super tall buildings, mechanical floors are placed at intervals to house extra chillers and pumps. This makes the system more efficient and manageable, reducing the distance water and air must travel. These hidden spaces are noisy, industrial, and essential for skyscraper comfort. Engineers designed them for easy maintenance and to minimize vibration. Without these behind-the-scenes powerhouses, skyscrapers couldn't function. They're the engine rooms of the vertical city. Every cool breeze you feel starts in these hidden spaces. Now let's see how climate, height, and people shape skyscraper cooling. Every building faces its own unique challenges. Designing a skyscraper's cooling system is a complex puzzle. Local climate is key. A building in Dubai faces different challenges than one in London or Singapore. Sun intensity, outdoor temperature, and humidity all dictate the size and type of cooling equipment. The building's height adds more complexity. Pumping water hundreds of meters up requires powerful pumps, and the stack effect can cause temperature imbalances. Engineers use zoned systems and sophisticated modeling to keep temperatures consistent from bottom to top. Occupancy matters too. Thousands of people and their equipment generate significant heat. The type of activity inside, from trading floors to libraries, affects cooling needs. Cooling demand changes throughout the day and year, peaking in the afternoon and summer. Modern systems use sensors and controls to adjust output in real time, balancing comfort and energy use. It's a constant balancing act for building operators. Every skyscraper is a unique challenge, shaped by its climate, height, and people. Next, let's see how these challenges play out in the world's hottest cities. First stop, the desert. In desert cities like Dubai, skyscrapers face extreme heat and dry air. Daytime temperatures can soar above 45 degrees Celsius, 113 degrees Fahrenheit, and the sun beats down relentlessly. Powerful chillers work non-stop to keep buildings cool. Dry air makes evaporative cooling in rooftop towers especially effective. Water evaporates, taking heat with it. The Burj Khalifa system can handle cooling loads equal to melting 13,000 tons of ice per day. To save energy, it uses ice storage, making ice at night, then melting it during the day to help cool the building. High-performance glass reduces solar gain, keeping interiors cooler. Water conservation is critical. Cooling towers use a lot of water, so engineers use hybrid towers and recycle condensate to minimize waste. Every drop counts in the desert. Desert skyscrapers are marvels of engineering, balancing massive cooling needs with limited water. The result: comfortable interiors in the harshest environments. But deserts aren't the only challenge. Let's head to the tropics. There, humidity is the real enemy. Here's how skyscrapers battle heat and moisture. In tropical cities like Singapore and Miami, skyscrapers face heat and relentless humidity. The challenge isn't just cooling the air, it's removing moisture to keep people comfortable. HVAC systems dehumidify by cooling air over cold coils, causing water vapor to condense and drain away. In extreme humidity, dedicated dehumidifiers or desiccant systems may be needed. Buildings like the Petronas Towers run their systems almost non-stop to fight heat and moisture. Engineers use insulation and vapor barriers to prevent condensation and mold. Corrosion is a constant threat, so materials must resist rust and decay. Air quality is a top priority. Fresh, filtered, dehumidified air is essential. Regular maintenance keeps everything running smoothly in these harsh conditions. Managing humidity is key to comfort and building longevity in the tropics. Now let's see how modern technology makes skyscraper cooling smarter and greener. Cooling skyscrapers uses huge amounts of energy, so efficiency is crucial. Modern HVAC systems are managed by Building Management Systems, BMS. Smart computers that monitor and adjust everything in real time. Sensors track temperature, humidity, occupancy, and air quality, letting the BMS fine-tune cooling for each zone. If a space is empty, cooling is reduced. If it's crowded, fresh air is increased. Energy recovery systems, like heat wheels, transfer coolness from outgoing air to incoming air, saving energy. High-performance glass, better insulation, and green roofs all help reduce the cooling load. Light-colored roofs reflect sunlight, keeping buildings cooler. Architects and engineers work together to design sustainable skyscrapers. The goal: maximum comfort, minimum energy use. Every innovation helps shrink the environmental footprint of our vertical cities. Smart systems and smart design are the future of skyscraper cooling. Let's wrap up with why all this matters for city life. Cooling isn't just a luxury, it's essential. The systems that keep skyscrapers cool are mostly invisible, but their impact is huge. Comfortable, climate-controlled buildings boost productivity and well-being. Without cooling, dense cities would be unbearable in summer. Offices and homes would be unusable. Skyscraper cooling makes modern urban life possible. allowing us to live and work high above the ground. As cities grow and heat waves become more common, efficient cooling is more important than ever. Engineers are developing new technologies, smarter chillers, renewable energy, and even district cooling systems. The goal: comfort with a smaller environmental footprint. From the basement chillers to rooftop towers, it's a symphony of technology working behind the scenes. Next time you step into a cool skyscraper, remember the engineering marvels keeping you